Welcome to the tutorial on building a front-end application with NEAR Protocol integration. Today I will show you how to create a modern web application that connects to NEAR blockchain, supporting both native NEAR wallet and Ethereum wallet. Before we start coding, you will find the complete starter code in the description below. To run this project locally, simply download the code and run npm install in the front-end folder to install all dependencies, and then the npm run dev to start the development server. Let's start by exploring the project structure and understanding the smart contract we'll be interacting with. First, let me quickly explain the NEAR smart contract we'll be connecting to. This simple greeting contract is written in Rust and demonstrates the basic patterns you will see in any NEAR Dapp. The contract starts by importing NEAR SDK and define a simple structure with one field, a greeting string. The NEAR contract state attribute tells NEAR this is our main contract state. The default implementation sets up initial contract state with a hello as a default greeting when the contract is first deployed. The contract has two public methods: getGreeting, which reads the current greeting without changing the state, and setGreeting, which updates the greeting and logs the change. These correspond to view function and call function in our frontend. getGreeting is free to call, while setGreeting requires gas fee and notification. Now let's build the frontend that interacts with this smart contract. First, let's understand the frontend architecture of our application. We are building a Next.js React application with a clean modular structure. I will show you each component and explain how they work together to create our user interface. Let's start with our navigation component. This is the heart of our user interface that handles wallet connection and provides navigation through the app. Let me walk through this code step by step. I imported Next.js component for optimized images and client-side navigation. Here I'm importing React hooks and the NEAR Wallet Selector hook for wallet connection functionality. I'm importing the NEAR logo for our navigation bar. Now I'm creating the navigation component. I'm setting up local state to manage the button action and label, and destructuring the wallet selector, get the signed account ID, and sign in out function. The signed account ID tells us if someone is connected to a wallet. The use effect is crucial. It dynamically updates our navigation based on wallet connection status. If someone is signed in, we show the account ID and send the action to signed out. If they are not signed in, we show login and set action to sign in. This automatically updates whenever the wallet connection status changes. In the return statement, I'm creating a Bootstrap styled navigation bar. The NEAR logo is clickable and takes users back to the home page. The button dynamically shows either login or logout with the account name, and its on-click function changes based on the current wallet state. This creates a seamless user experience for the wallet management. Now let's look at our cards component. This creates the main navigation element that guided users through our application. I'm importing Next.js link and CSS models for scoped styling. The first card links to NEAR official documentation. I'm using target blank to open it in a new tab, and the arrow span gives users a visual cue that this is an external link. The second card links to our smart contract demo page. Both cards are use consistent styling but serve different purposes in guiding user flow. Now let's examine our home page that brings everything together into a cohesive landing experience. I'm importing Next.js image component for optimized image rendering. Here I'm importing the logos, our cards component, and CSS modules for styling. In the main content area, I'm creating a center layout that showcases the integration between NEAR and Next.js. The logos are sized proportionally, and plus sign clearly indicates this is about combining these technologies. Finally, I'm rendering our cards component in a grid layout, creating the main call to action area. These three components work together to create a professional, user-friendly interface. The navigation provides consistent wallet management across all pages. The cards guide users through the application flow, and the homepage creates an attractive landing experience that clearly communicates on NEAR plus Next.js integration. Now, let's implement smart contract interaction functionality. This is where our application becomes a true Dapp, connecting to NEAR blockchain. I will show you how to configure network settings, manage contract addresses, and implement both read and write operation with a smart contract. I'm creating a config.js file to manage our network settings and contract addresses. Proper configuration management is crucial for our dApps because it allows us to easily switch between development and production environments. I'm defining contract addresses for both mainnet and testnet networks. The mainnet address is for production with real tokens, and while testnet is for safe testing. Here I'm setting up the EVM chain configuration that allows Ethereum wallet to interact with NEAR. NEAR provides EVM-compatible endpoints that translate Ethereum-style transactions into NEAR transactions. The chain ID is 397 and 398, are NEAR-designed identifiers for its EVM-compatible layers. Here, I'm exporting our current network configuration using an environment management pattern by setting network ID to testnet. The hello NEAR contract automatically resolves to the testnet contract address, and EVM wallet chain selects the testnet EVM configuration. This allows switching between testnet and mainnet by changing just one variable. Now I'm going to show you how to implement wallet connection. This is where we'll write the actual code that allows users to connect both NEAR native wallet and Ethereum wallet to our application. We'll start with Ethereum wallet, support using Web3Modal, that configure our main application to support multiple wallet types. I'm creating a new file called Web3Modal.js. In this wallet folder, this will handle in the complex task by bridging Ethereum wallets to work with NEAR protocol. Let me start by importing the necessary libraries. These imports are the foundation of our Ethereum wallet integration. The reconnect function helps mainnet wallet connection across browser session. Create app kit creates the wallet connection model, and NEAR testnet provides NEAR testnet configuration. And finally, WAGMI adapter is a bridge that allows Ethereum wallet to communicate with NEAR protocol. App setting up project ID for wallet connection service. In production, you would get your own from the Wallet Connect Cloud dashboard. Now I'm creating the WAGMI adapter, which makes Ethereum wallet compatible with NEAR. We're configuring it to work with NEAR testnet, not Ethereum mainnet. This allows MetaMask and other Ethereum wallet to interact with NEAR blockchain. Here I'm setting up the app kit model that creates a wallet connection interface. This model handles wallet detection and connection protocols. The adapters array tells to model which blockchain networks to support. We are passing our WAGMI adapter, configured for NEAR. The Enable Wallet Connect option activates QR codes, scanning for mobile wallet, expanding our wallet ecosystem beyond just browser extension to include mobile wallet and hardware wallet. I'm configuring the model features. I'm enable analytics by disable email and social logins because NEAR supports only external owned accounts, not smart contract wallet. I'm also disable swaps and on-ramp since we are focusing on simple wallet connection. Setting code base to external owned account only for the same reason. I'm showing all available wallets for maximum user choice. This adds automatic reconnection functionality for Ethereum wallets. I'm first checking if we are in browser environment with type of window, then looking at local storage to see if a user was previously connected with an Ethereum wallet. The local storage key NEAR Wallet Selector recently signed in wallet is where NEAR Wallet Selector stores connection history. If the user was connected with an Ethereum wallet, I automatically attempt to reconnect them using the WAGMI configuration. This creates a seamless user experience where users don't have to reconnect their wallet every time they visit the site. Now let's configure our main application in app.js. This is where we'll set up supporting for multiple wallet types, both NEAR native wallets and Ethereum wallets we just configured. I'm importing global styles and NEAR Wallet Selector model styles for professional user interface. I'm purporting a setup functions for a comprehensive range of wallet providers. This includes NEAR native wallets, hardware wallets like Ledger, mobile wallets, and our Ethereum wallet bridge. This gives user incredible flexibility in choosing way how they want to connect. I'm importing the provider for wallet functionality, configuration settings, and our navigation component. Here, I'm importing the Web3Modal configuration we just created. Now I'm creating the wallet selector configuration. This is where all our wallet types come together. Notice, now I'm passing our Wegme configuration to Ethereum wallet setup. This connects our Ethereum wallet model to NEAR Wallet Selector system. Some wallets can be pre-configured with contract ID for enhanced user experience. Finally, I'm wrapping our entire application with a wallet selector provider. This makes wallet functionality available to every component through React context, ensuring consistent wallet management across the entire application. Now I'm creating the smart contract integration page in Hello NEAR folder index.js. This component will demonstrate both reading data from and writing data to a NEAR smart contract, showcasing the fundamental operation that powers all Dapps. I'm importing our cards component, React hooks, and CSS model for our interface. Here I'm importing our contract configuration and the wallet selector hook for blockchain interaction. Here I'm destructing the wallet selector to access the most important functions for Dapp development. Signed account ID tells us authentication status, view functions reads data for free, and call function writes data with a gas fees. Now I'm setting up comprehensive state management for our smart contract interface. The greeting state holds a current value from the blockchain, initialize it with loading. It gives users immediate feedback the data is being fetched. New greeting captures user input before it sends to the blockchain. Logged in tracks the wallet authentication status so we can show different UE elements to connected versus unconnected users. Show spinner manages loading states during blockchain transaction, which is crucial because blockchain operation can take seconds and users need visual feedback that something is happening. This use effect demonstrates reading data from a smart contract. Hello NEAR contract using NEAR view function. View functions are read-only operations that query blockchain state without requiring authentication or gas fees. I'm calling the getGreeting method on our contract, which executes on NEAR runtime and returns the stored value. The empty dependencies array ensures this runs once when the component mounts. And then callback updates our reg state with a blockchain response. These use effects correct the wallet connection status. When someone connects their wallet, signed account ID gets the account name. When they disconnect, it becomes null. This converts this to true or false, automatically update to our UE based on connection status. I'm implementing the smart contract operation using call function. This calls the setGreeting method on our contract, passing the new greeting as an argument. Unlike view function, call function requires the users to sign a transaction with their wallet and pay gas fee because they modify blockchain state. Then, callback executes after the blockchain confirms the transaction. Inside it, I immediately read the update value, back from the contract using view functions to ensure our UE displays the actual blockchain state, not just our assumption. This write then verify pattern is important because blockchain operation can sometimes fail or behave unexpectedly. I'm implementing UE updates showing loading feedback and updating the display immediately for better user experience. In the user interface, I'm displaying which contract we are interacting with for transparency and debugging. I'm permanently displaying the current blockchain state. This is the right interface that only appears when users have connected their wallet. The hidden logged in ensures you cannot write to the blockchain without authentication. The input field uses on-chain to capture user tags in real time as they type, updating our new greeting state. The button implements dynamic loading feedback. When a transaction is processing, it hides the saved tags and shows Bootstrap spinner. This visual feedback is essential because blockchain transactions aren't instant like regular web interactions. They can take 1-3 seconds to confirm as the transaction propagates through the network and gets validated by validators. Users need to clear indication and that their transaction is being processed and hasn't been lost. For authenticated users, I'm showing a clear message prompting them to connect their wallet. The hidden logged in ensures this only appears when users aren't connected. The cards component provides navigation to other parts of the application, giving users option even if they don't connect a wallet. I did two mistakes. First, in the file app.js, I misspelling match props in the app where you write component, and in the index.js I don't need to write enter. Now let me show you how the completed application works from a user perspective. When you first visit the site, you will see our landing page with the NEAR and Next.js logos. Notice the navigation bar at the top shows login, since no wallet connected yet. If I click on NEAR integration, it takes me to our smart contract integration page, where I can see the current greeting from the blockchain. It shows hello, which is our smart contract default value. It should be hello, but right now it's another, as someone already used this website, changed some values in our smart contract. Since I'm not logged in, I only see the current greeting and a message asking me to log in to change it. Now let me connect it to a wallet by clicking login in the navigation. The wallet selector model appears showing all available options. NEAR native wallets like my NEAR wallet and Ethereum wallets like MetaMask. I'm connecting with NEAR native wallet, Meter wallet. Once connecting, notice how the navigation automatically updates to show log out with my account name. Now back on the smart contract page, I can see the input field and save button have appeared since I'm authenticated. I can type a new greeting, click save, and watch as the spinner appears during the blockchain transaction. After a few seconds, the greeting updates to show my new value stored on the NEAR blockchain. To verify the transaction actually happened on the blockchain, let me check NEAR Blocks Explorer. I will navigate to NEAR Blocks.io and search for our contract address. Here I can see all the transactions, including the recent set greeting call I just made. This proves our frontend is working properly with the NEAR blockchain, not just updating a local database. Congratulations, you have just completed the entire frontend plus NEAR integrations. We have built a great Dapp that demonstrates all the essential patterns for the blockchain development. Our application supports multiple wallet types, including NEAR wallet and Ethereum wallet. We have implemented proper UI and UX, view functions for free data reading and using call function for data writing. This foundation provides everything you need to build more complex apps. You can extend to Python to create marketplaces, social applications, gaming platforms, or any other blockchain-powered application, while maintaining an excellent user experience and across different wallet ecosystem. Subscribe for more NEAR tutorials and drop your questions in the comments. See you next time.